Okay, in your notes, you'll find a section where we talk about vertical stretching and shrinking. Okay. And today, what we want to do, our goal is to look at transformations that have shrinking and stretching. But we also want to examine the four effects of the different type of transformations that we've seen on a function as a whole. So today is a pretty cool lesson day. You're going to have to lean in and dig deep, though. All right? You're definitely going to get a problem like this on your test. This is something you're going to want to know how to do and to do well. Okay? So if we have a function and we would like to transform that, and what we do is we put a constant in front of it, okay? Is that constant on the outside or the inside? It's on the outside, so therefore it will affect it vertically. And so this is a vertical stretch by a factor of A. So suppose A was 3. Then it's going to be stretched by a factor of 3. Suppose it was 10. They'll be stretched by a factor of, suppose it was a 1/2. Then it will be, you could say stretched by a factor of 1/2, which is really, it's going to be compressed, right? It's going to be shrunk, right? So, but that's the way I like to think of it. Whatever number's in front, that's what we do to it, okay? Horizontal is different, okay? If we take a function and change it to g of a times x, is the a on the outside or the inside now? It's on the inside. And so therefore it affects the function horizontally. So instead of a vertical, this is a horizontal stretch by a factor of, this is very, very important. This is where you got to lean in. You got to trust me. You got to focus. Are you ready? Positive? Are you ready? Okay, here we go. Suppose you have y is equal to x minus 3 quantity squared. Is that a shift to the right 3 or left 3? Right 3. It's opposite of what you thought, right? When it's on the inside, it's opposite of what you think. Opposite of what you think. So this is a horizontal stretch by a factor of 1 over a, the reciprocal value. Now, I'm going to try to tie this together for you, but I will admit that many people kind of don't fully grasp this, doesn't fully sink in. But if I had an a value equal to 1/4, okay, all right, what's the reciprocal of 1/4? So it's a horizontal stretch. Suppose I had an a value of 1/2. What's the reciprocal of a half? 2. So it's a horizontal stretch. Suppose I have an a value of 3. The reciprocal is, so it gets smaller. Now, I'm going to try to tie this together so you understand it. I'm taking a shot here. I don't know if this will work for everybody, but we'll see. Y is equal to 3x quantity squared. Is it 3 on the inside or the outside? Inside. What's the reciprocal? 1/3. So will it be a stretch or a compression? Yeah, it'll be smaller, right? Now, here's why this should make sense. Isn't this the same thing as 9x squared? Is the 9 on the outside or the inside? It's on the outside. So vertically, will that be a stretch or a compression? Stretch. If you take something and you stretch it vertically, Isn't that like compressing it horizontally? Yeah. See how those connect? No, no, it could really be anything. So we could do, the square parabola is maybe the easiest thing to see, but we could say 2x quantity to the third. And if we have y is equal to absolute value of 2x minus 6, okay, that again will be, so that the parent function looks like that, right? There's two ways which I think about this, okay? Number one, the 2 is on the inside, right? So what's the reciprocal of 2? So is it going to get smaller horizontally or bigger horizontally? Smaller. Yeah. If you think about it, it has a slope of positive 2 and negative 2. So you can think of it as a vertical stretch for horizontal compression. It works no matter what kind of function you give it to, okay? Let's summarize this by looking at this piece right here, okay? And I know that this looks goofy to look at, but this is how I think of all of our function transformations. Let me give you an example that we can consider. Say y is equal to negative 3 times the absolute value of 2x minus 5 plus 1. So that's something that I would hope we would be able to give a general sketch of at some point. And as I look at that type of a shape, I always think of what this last number does. I always think on the outside first. What will this plus 1 or this plus d do to the function? Vertical shift. Good. Yep. 1 down, 3 to go. So everybody okay with that 1 on the end there? Okay, good. So we've classified that. We're ready to move on to something else. Let's look at this a value up front. This negative 3 is on the outside or inside? Outside. What's the negative going to do to it? Yeah, flip it over the x-axis, so vertical reflection, right? So if a is negative, then we have a vertical reflection, right? So if a is negative, it's a vertical reflection. And then what will the 3 do? Will it make it stretch vertically or horizontally? Will the 3 make it stretch vertically or horizontally? Vertically, right? Yeah. So, and a vertical stretch. By a factor of a, okay? So we multiply the output by 3. 3 times whatever it would have been before, okay? Good. So we got 2 down. Now I'm going to go to the inside, okay? And you're not going to see it written this way in the book, okay? After years of teaching it, I think that this is the best way to do it. Let us look at the 2x minus the 5. Anybody want to give a guess here what the horizontal shift is? Do you remember what I tell you to do when you find the horizontal shift? You look at the inside and set it equal to 0. What would give you 0 on the inside here? 5 halves. Yeah. So the inside piece provides a horizontal shift. Solve bx minus c equals 0. And when you solve that, that will tell you your horizontal shift. Okay? So that's how C and B really impact. But B also has another impact. And that's what we talked about right here. Maybe I should have used a B here instead of an A to try to tie it together. But the fact is when we have a number multiplying on the inside, first of all, what if that B value was negative? Then what would happen? You have a negative on the inside, what happens? Reflect over the y-axis, so that's a horizontal reflection, right? So horizontal reflection, good. And then we said that B also creates a horizontal stretch, right? So horizontal stretch take spelling class again. By 1 over b, by a factor of 1 over b. So it's the reciprocal value. Okay. So after looking at many of an ACT exam, as well as an AP calculus exam, as well as just book problems, I think that this is one of the best examples that can summarize our learnings. What I want you to do is I want you to make an X, Y tree here, and I want you to plot the following points. We have -2, -1. We're going to go -1, +2. +1, +2. And 3, 0. And we're going to make a shape, and it's going to look like that. First questions first, true or false, that's a function. Why is it a function? Because it passes the vertical line test. And the definition of a function is a relation in which every element of the domain corresponds to exactly one element of the range, which you have to know verbatim perfectly for the test. And you will. We'll practice it tomorrow. So juniors will have to practice on Thursday. Okay. So let us now look at what we're trying to do. This is just a wonderful, in-depth, critical thinking type problem. This is where you actually develop more neurons in your brains today, folks. I'm not kidding. It actually happens. It says, this is f of x. We want to graph and provide a table for y equals 2f of x. So here's the thought process I carry through my brain. Is the 2 sitting on the outside or on the inside? Outside. So will it affect it vertically or horizontally? Vertically. Okay? So does that change the x values or the y values? If it changes it vertically, that affects the y values, correct? So here's the deal. The new coordinates for this shape, the x values stay the same. -2, -1, 1, and 3. But the y values will change because this is saying 2 times the output, 2 times the function value, okay? So when we have a 2 out front, what does that do to the graph? It creates a vertical stretch by a factor of 2. So what do you think I do to all the y values? Multiplying by 2. Very good. So -2, 4, 4, 0. You will have to do a problem very similar to this on your assignment, on your study guide, on your test. It is extremely important that we know how to do it for our learning as we move forward. Now, the actual coordinate planes I've provided are not each, they're not identical in size, okay? And so it may look a little deceiving, but do you see that this is stretched twice what that is? And it's stretched about the origin. I want to keep that clear, that the origin is the point that's held in the exact same position, okay? All right, so we move along, all right? So I got another xy1, and I've got this 0.5x, and I got this +1. When we apply our transformations, you must do so in accordance with the order of operations in which they occur. So would you add 1 first, or would you multiply by 0.5 first if you were to plug something in for x? You multiply by 0.5. So I have a 0.5. Is on the inside or outside? Inside. So is that horizontal or vertical? Horizontal. X values or y values? X values. Now let's describe, what does a 0.5 on the inside do? Well, it's going to be opposite. What's the reciprocal of 0.5? 2. So is this going to be a stretch horizontally or a shrink? Stretch by a factor of 2. This is a stretch by a factor of 2. Got that? So what do you think I do to the x values? Multiplying by 2. What do you think people might do on the test? Multiplying by 0.5. Does that seem reasonable? Of course it seems reasonable, but it will not give you the right shape. Then I add 1. Is the plus 1 on the outside or the inside? Vertical or horizontal? Vertical, x values or y values? Y values. What does the plus 1 do to a graph? It shifts it up 1. So what do you think we do to the y values? Add 1. Add 1 to the y values. I have negative 2, positive 3, and 1. What did I do? Did I screw up? Oh, sorry. Thank you. I was getting excited. It's a big day today. It's my mom's 65th birthday. Yeah. We called and wished her happy birthday in second hour. We sang for her and everything. Oh, you could hear us? Yeah, yeah. Were you really? Okay. Yeah, it was a good time. Yep. And then my wife has been home with my kids for 12 years. And today she went up for her first sub job. So she's subbing for first graders today. So I'm hoping it's going well for her. So hopefully they don't give her the finger or swear at her or anything. So never know, first graders these days. Okay. So does my new shape look like it's stretched horizontally? Can you tell it's shifted up 1 unit from what it was? Yeah. Okay, let's go to the next one. Now we have 3 things happening here. Oh my gosh. What do we do first? The negative, the -1, or the -3? -1 due to the order of operations. Is the -1 on the inside or outside? Inside. Horizontally or vertically then? Horizontally, will that affect the x values or the y values? X values. Okay, so now, instead of subtracting 1 from each x value, let's actually think about what does it do. What does the -1 do? Shifts it to the right one. So therefore, we will add 1. Does that make sense? Do you understand why people subtract 1? But you have to think about what it's doing to the graph. Okay? All right. Now I got the negative and the -3 are on the outsides, right? So do I apply the negative first or the -3 first? The negative due to the order of operations. So what do you think I do to the y values then? Make them all negative and then subtract 3. So we're going to take the opposite of all those values, and then we'll subtract 3. So the opposite of -1 is +1, -3 is -2. -2 minus 3 is -5, -5, and -3. I'm going to plot these. What's that? Right here. So we're applying the negative. We're going to make these opposite in value and then subtract 3. So make the -1 negative, so +1. Then subtract 3 to get -2. -2 minus 3, -5. Thank you for asking, because somebody else in the class had the same question, just wasn't asking. Okay? Don't ever hesitate to ask, you guys. Okay? All right, well, does that look like it's been flipped vertically? Yeah. Does it look like it's been shifted? Does it look like it's been stretched or compressed at all? And it shouldn't be, should it? So it's a nice way to verify our answer. Okay, the last one. It's exciting, isn't it? Okay, you lead me through it. Flip what? Horizontally. Excellent. So I have a horizontal flip. So what does that do? X. What about the X? Make them all opposite in value. Very good. Multiply by -1. So I got 2, 1, -1, and -3. Which 2? Okay, times 2 and to what? To the y value. So the y values I'm going to multiply by 2 and then add 2. Okay? So 2 times -1 is -2 plus 2 is 0. 4 plus 2 is 6. 6, 2. We can graph these. So does that look like a horizontal reflection? Yeah. Does it look like it's been stretched and shifted? Yeah, exactly. So you can see why on the ACT, it's awesome if they ask you a question. If you take f of x and make it into, you know, and make it into -2 times x minus 3 plus 1, and they say, what are the transformations? You say, well, a vertical stretch by 2, a vertical reflection, shift to the right 3, and up 1. That's the type of stuff that they're looking for you to be descriptive, okay? And so that's a really good question, which we've just been able to kind of work through, all right? So good work, all right? Your assignment, you can actually get just about all of it done in class if you kind of get to it. But it is page, where are you? Page 194, 1 through 12. The book pages are online, and I want to iterate that please make sure that you check your answers.